Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer, sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
S.O.L.I.D.
Freaking solid, babe.
The world of object-oriented programming has lots of principles and patterns to help us build better code. At the core of these are ones defined or elaborated on by Uncle Bob Martin in his many writings on object-oriented programming. S.O.L.I.D is a mnemonic acronym for 5 core principles to designing and implementing solid object-oriented code. We'll be diving into each one of these 5 principles, talking about what it is and how it is implemented. But before we get started, Will, what have you been fighting this week?
I've been fighting timer issues. Lots of timer issues. In fact, code that starts, that kicks off a timer and says, okay, when this timer fires, do this thing, right? And then you go into the event for that timer, and this timer in here is kicking off a couple other timers, then doing some stuff and returning. The next time the timer comes back in, it shuts off the other 2. I don't know what they were meaning. I'm looking at this just going, I don't understand what's going on here. And I think I have some threading issues going on, but it's not my code. And so I'm trying to troubleshoot this. The weird thing is like you would look at that and you go, okay, this has to be falling over. And this has to be breaking things. And it's not.
Huh.
It's apparently working perfectly, which is really bothering me. I got nothing. Yeah. But I'm trying to prove that it's busted, and I have no evidence.
I've been there. Yeah.
How about you?
Buggy. Got another ORM burn today. Thanks, in Hibernate. Reading from a view on many-to-one relationship, it's creating entities for all of the times a row is used when I'm just trying to pull back one, and then it's giving me an error stating that there are multiple rows with the same identifier. Well, of course, because you're seeing it for all the times that it's doing it. I'm still not sure how to fix the actual problem. I had to kind of code around the issue just to get things working. Tomorrow, I'm done with this old app that I didn't write. We have our review in retro. This is the application that I inherited, I guess, the first Christmas that I was at this job.
Yeah.
And then on Wednesday, I get to go back to the app that I've been working on and have built from the ground up. I'm really excited to get back to my app.
It is awful fun to get into other people's code and just and try to reverse engineer the brain that was happening. How did you think this worked?
Right. I spent some time with my family this past weekend. My sister was passing through, stayed with mom, so I got some quality time with her and my nieces. My sister even mentioned that I've lost weight, which that's, really nice. With the weather getting nicer, I've been walking outside more and even thinking about taking my bicycle out for a ride. Speaking of riding, I've got something handlebar related for IoTs. Now, this is handlebar related to a bicycle handlebar and not handlebar, the JavaScript library. It's a product called the Velco Wink Bar. It's a smart connected handlebar for your bicycle that pairs with an app on your phone. It allows for GPS navigation when riding, integrated headlights, and even geolocation if your bike is lost or stolen. The app is available in the Apple Store or Google Play, and it lets you set routes for your bike to guide you. So it will tell you, which ways to go. You can even get metrics about your ride from the information in the handlebars. That's really cool. I'll have a link to their website in the show notes. Who's talking to us this week?
Well, we grabbed an email from John. Says, just wanted to say thanks for such a great podcast. So refreshing that you discuss general programming concepts instead of some hyper-specific framework. Surprised at how much I learn and retain from each of your episodes. You two have a true talent for delivering really abstract concepts in an understandable and entertaining way. I listen to a ton of developer podcasts, but yours has really helped contextualize a lot about the programming primitives. Most of the time, conversations about these topics go right over my head. All sounds like some really martial language to me. You help humanize coding.
John, thanks so much for the compliment. That is what we are going for with this podcast. We both really enjoy talking about those deep topics and putting them in terms so that anyone can join the conversation.
Yeah, and I personally have a deep-seated hatred for the over-intellectualization of some things like this, making it, it takes the beauty out of it. Mm-hmm. And that's the thing that bugs me, and that's what I try to push for, is to put it back.
Like, there's a lot of intellectualism in it by nature, and so adding that complexity. Now, I understand some of it, like putting it into the terms of math or the logic terms, it's needed to make it formalized and generic.
Yeah.
So like to genericize those concepts, it does have to get complicated wording, but sometimes the way to understand a concept is not the generic, it's through example. And that's how Will and I both learn. And that's, we grew up in a culture, going to church and stuff, learning through parable and hyperbole and things like that. So that's the way that we try to express things. Right. And by giving specific examples that can be generalized. We really appreciate your compliment. Send us an email with your contact information because we got a Complete Developer water bottle just for you. Guys, if you'd like your very own Complete Developer water bottle, leave us a review on iTunes or comment on the website or any of our social media. We post all our episodes to Twitter, Facebook, LinkedIn, and Google+. We're also on Tumblr, Path, and Instagram. Also, check us out each week on Facebook, Twitter, Periscope, and YouTube Live, where we talk about what's going on in the tech world and answer some listener questions. You can join the conversation anytime via Slack by going to slack.completedevelopernetwork.com. It's that time of year again. Will and I are getting ready for Nashville's premier polyglot technology conference. This year, Music City Code has combined forces with Music City Agile and Music City Data, and by their powers combined, they form Music City Tech.
Have you ever wondered what it's like to record a podcast? Well, sit in the audience as we host a panel at the conference that will later, through the magic of BJ's extensive editing talents, become an episode. Meet us and the Junior Developer Toolbox crew at our booth and get some cool CDP swag.
Music City Tech is a 3-day event, May 31st through June 2nd, consisting of simultaneous conferences, Music City Code, Music City Agile, and Music City Data, each focused on a particular community of technology professionals held at Vanderbilt University. Tickets went on sale April 1st. Speaker selections have been finalized, and the sessions can be found at session.musiccitytech.com. You can get tickets by going to completedeveloper.musiccitytech.com.
In object-oriented programming, we have a lot of patterns and principles to help us design and build better code. Many of these were written or codified by Robert C. Martin, also known as Uncle Bob. The goal of these principles is to make it easier to develop, maintain, and scale your code. They also make it easier to recognize and avoid code smells, as well as improving the refactorability of your code.
S.O.L.I.D is a mnemonic for the first 5 principles that Uncle Bob promotes. They can and should be applied to any object-oriented design and serve as the core of certain methodologies built around object-oriented programming, such as Agile. He states that these are not laws nor rules, but advice on how to design and build better code. Like with design patterns, these are guidelines that in most circumstances will lead to the best possible code.
We're going to go through each of the 5 principles, breaking them down, discussing how they are applied, and providing some insights and background as we go along. While the outline is language agnostic, it's hard to discuss these without talking language specifics. There are lots of examples, especially in C and C++, but you can find samples in most languages, even including things like PHP.
Each point that we're going to talk about starts with a quote, and some of them are secondary or tertiary sources, so they may not be exact, but more paraphrases. Now, I'll be honest with you guys, I wrote this and the episode was a bit of a pain to write because I could define all the principles in about 5 minutes, but spend the rest of my career understanding them. So getting a good depth without going too far it was a bit of a challenge to write this.
The first one is the single responsibility principle.
This focuses on actors and high-level architecture. And a quote from Uncle Bob is, "There should never be more than one reason for a class to change."
And by change, we mean anything you do to the code that changes functionality of that method or class. This may be from adding a new feature, correcting bugs or errors, or refactoring and cleaning up the code.
Mm-hmm. A responsibility here is what is being done by this particular part of your software. Software should be a conglomeration of highly specialized pieces of code working together towards a specific goal.
Yeah, and keeping the responsibility down in a single piece of the code reduces the need for other areas to know too much about it. Or in other words, it keeps the coupling loose.
The work done in these areas of the code needs to be done in isolation. So, the idea here is that you have one area of code, one method, one class, whatever, with a specific functionality. So it is responsible for doing one thing, taking in certain things and putting out certain things, but one responsibility.
Right. Not all the responsibilities.
Right. This is based on Tom DeMarco's principle of cohesion, in that cohesion measures how strongly elements in a module of code belong together or are related to one another.
Yeah, and it's a qualitative measurement using a rubric to determine high cohesion versus low cohesion. And there's just about enough stuff for an episode just on that topic, on how that works. But this ranges from coincidental, which is the worst form of cohesion, to perfect or atomic cohesion.
There's 7 levels in between the two. Coincidental cohesion happens when parts of a module or class are arbitrarily grouped together. So there's no real reason or functional reason for them to be together. They're just together because it's a helper class and it's where all the little helper things
go.
Yeah.
Yeah. Or because the developer had that class open and they just said, I'll just add it here. And the latter seems to be a really common thing in older code. It's not so common now because everybody kicks and screams about it, but 10, 15 years ago, it was everywhere.
I've heard of, a lot of people have gotten away from the God classes.
Yeah.
But I heard the term today listening to our friends over at Coding Blocks, demigod classes.
Yeah.
Where it's not an all-powerful class that has everything. There's 7 or 8 really big classes that pretty much control the whole thing.
Yeah.
And so this is what I think of with this coincidental cohesion, where each one of these classes just happens, it happens to have a bunch of things in it that really don't relate exactly to each other, or may very loosely relate. They don't really have any functional relation.
And you'll see this, we talked about this being in classes, and that's what the whole, this whole discussion is about. But you'll see this all the way down to the method level and all the way up to the application level.
Yeah.
Which is, it's wild. It's a problem of human design that goes both ways.
Mm-hmm. And I struggle with this some at work because I have a class for doing my conversion between my view model and my data model.
Right.
And it's a converter service. And so I want to put other converters in there too, because they're doing certain conversions, but I'm like, no, this is for that specific one. And then I have to create another one. Is I recently built a number generator service to where you have an object with a list of objects in it. And so you want a unique number on each member of that list for that object, but it resets for every object.
Right. So it's a transient identifier. Right.
Yeah.
Yeah.
And I have been putting more stuff into that class, and I've been looking at it going, all right, I can see how it relates because it's related domain wise to each other. But I'm like, is this a little too far down the cohesion?
Yeah. And I'll run into this, especially with C# extension methods. Mm-hmm. Right? Because you put all those in a class and they aren't addressed by that class. They're addressed by whatever is this parameter. That's the first parameter.
Right.
And so you can get away with it for a long time. Uh-huh. And then eventually you look and that thing's got 100 methods and you're like, this is just a bucket of crap. What is this?
See, I do my converter service as extension methods.
Yeah. So you got the same issue, right?
Yeah. The exact same thing.
And I really do think that particular feature of C#, as much as I love it, really, really encourages this bad behavior.
Right. So on the other side, perfect cohesion would be a module containing only a single atomic element. And let's be honest, guys, perfect cohesion is not practical in business applications. In practice, cohesion is a balance of the unit's complexity and its coupling. The goal is for functional cohesion, as that happens when parts of a module are grouped together based on accomplishing a single well-defined task.
I would agree with that. And there's some criticisms of this principle. When it comes to bugs, refactoring, performance improvement, etc., do they count as a reason for change?
Yeah, because if a bug or refactoring counts as a reason, and you're only allowed to have one reason, it becomes the sole reason for that class to exist.
Right.
So that's where this criticism comes in.
The other thing is the definition of a reason to change is too ambiguous. Like, some of your code changes because the developers just don't like it.
Mm-hmm. Responsibilities could be too broad or too narrow. There has to be an agreement on what is a valid responsibility. And this goes into your team agreement or your standards for developing those sorts of things.
Yeah, I mean, it's really true of all the coding problems that you run into, that if you dig deep enough, they're personnel problems.
Mm-hmm.
And this is where that line is.
So the next letter in S.O.L.I.D is O, and that stands for the open-closed principle. This has to do with the class design and feature extensions. I have a quote from Bertrand Meyer that says, "Software entities, classes, modules, functions, etc., should be open for extension, but closed for modification."
Yeah, so you need to balance between maintaining single responsibility and changes in scope as you develop.
Keep your existing or legacy code as immutable as possible while allowing new code to extend that functionality, adding in new features. This extends the single responsibility principle by saying if you need to make changes to a class, you have to extend the class rather than alter it.
Right. Yeah, I mean, it's a big backward compatibility thing is really what that comes down to, is like, don't make structural changes that break the rest of your system. I know, with your system, you guys control the deployment to your own environment.
Right.
But this is really, really critical for what I work on, because we don't.
Mm-hmm.
And we're a white label product, and we have clients that are hitting our DLLs.
Yeah. Okay.
Potentially. And so if we break something, like we break a signature, a public signature, it could bust their stuff in production.
Yeah.
In many cases, because we do have a few clients that love to tip. You know what I mean by tip, right? They test in production.
Mm-hmm.
Yeah. So it really gets you really quick. Or if you're in a big environment, with a whole lot of other developers, like you can really get in over your head with this.
So breaking this down, open for extension means that behavior can be added to existing modules or classes of code to make it act in new and different ways. This could be adding fields to data structures or adding new functions. And reasons for extending your code can come from changes in scope of a project or adding new features to existing legacy code. Lots of different reasons.
Yeah. And, adding features to legacy code can be its own can of worms, because sometimes you find that stuff doesn't quite work the way you think it did, because, that the part of the reason it's legacy is because knowledge has been lost.
Mm-hmm.
And so you'll try to extend that code, and then you find out that somebody is doing something with reflection over it, or like you have a JavaScript object and you're like, oh, I'll just add another property here, but it turns out there's some weird piece of code over here that's looping through the properties and doing something with them, and yours busts it, and you had no way of knowing because you added functionality, but you didn't realize that, oh no, you changed a signature there that they were expecting. So you got to be careful with that. Not saying that I've been burned by it this year, but oh man.
So I was working on a side project, and they wanted to add some functionality to some not too far back legacy. I mean, this is like web API, Angular JS type stuff. So it's things I'm familiar with, but their database structure was a lot of tables, but it was just like not very normalized. And you could tell the person that wrote the API didn't really quite grasp object oriented. It's like it was like it was their first attempt at a web API.
Yeah.
And so after their developer left, I got hired on to, add this functionality. I add the functionality, build some tables for them in the database, and they had someone else do the front end, so I didn't have to touch that. Go away, and, they kept me, I won't say on retainer because they weren't paying me, but they kept in touch, and then I had to come back in a couple of months later and explain to their database person how to get to the information because they didn't understand how a join table worked.
Yep.
And I'm like, what?
Well, speaking of the database thing and this open-close principle, adding columns to a database, you would think that this would be an extension. But what it actually does is you'll have a lot of people that are really crappy with databases that are doing a lot of select star, and you just change the signature of other things.
Oh, yeah.
Or if you add a column that's non-nullable, like it
really messes with them.
Yeah, this is a really hard one to get right. Like it's a goal to go for, but it's not something that any of us does as well as we would like to pretend.
Right. So closed for modification ensures that the original source code for a module or class is not changed. Therefore, when adding new features, you don't want to affect the existing functionality.
Yeah, and you may not be the only one using the code that you're changing. Like, where I work, there's a distinct possibility that a client is using a library that we have. Now, we've told them, hey, you can only use certain things, but that doesn't mean that they don't.
Right.
Doesn't mean that they obey it. So you have to be cognizant of that. And so you try not to break things.
When adding new features, you don't want to affect the existing functionality. You may not be the only one using the code that you're changing. Meyer's idea here was to avoid having to change all the areas that we're calling that code or that library.
Right. And this was back in the days of DLL hell,
right,
as we like to refer to it. Especially like the old COM setups and all those kind of things where you load a different version of the DLL and you've got pointers to functions inside there and those have moved. Mm-hmm. Like that's really hard to deal with.
Applying this principle requires the use of abstraction and inheritance. Meyer's approach to applying the principle relied on the use of inheritance, and it uses implementation inheritance to create a new implementation of the class. This implementation would then contain the existing properties and behaviors of the inherited class. It could then be added to or modified without affecting the class it was inheriting from.
Right.
The polymorphic approach uses a single abstract interface that allows for different implementations. This involves inheriting from an abstract base class so that the original class doesn't change. The interface can be reused, but not the implementation.
Right. It's sort of the difference between the box for an electrical plug and the socket that the plug goes into. One of those is just an interface and the other one is an implementation.
Mm-hmm. Existing interfaces are closed to modification, but the new implementations of the interface may themselves be added to.
Of course, that said, I do see an awful lot of people that will use interfaces as a way to get something on a class so that when they have to change something, they change it on the interface and the compiler breaks in all the places. Uh-huh. Like that's a trick. I don't know how many people I know that do that. Probably like 90%.
Oh, wow. Really?
Yeah. Because it's just like, oh, we're used to these tools now. Back in the day, you didn't have all this stuff. And so it was a little different. And you might be shipping header files and, binary code or whatever. And
okay. Yeah.
It was used somewhere else versus it's all in the organization and we've got a nice compiler. And
I wouldn't have, I get that, but I wouldn't have thought to do that.
Yeah.
Because you taught me to code right.
Right. It's not and you can be a little bit faster and looser again if your stuff is on-prem.
Yeah.
But it burns you bad if it's not.
So the L in S.O.L.I.D stands for the Liskov substitution principle. And this has to do with subtyping and inheritance. So I have a quote, and based on our comment, we're going to say the complex mathematical way of describing this and then get into a description and probably a few examples. And this is from Barbara Liskov. It says, let phi of x be a property provable about objects x of type T, then phi of y should be true for objects y of type S, where S is a subtype of T.
So basically, said in English instead of mathematics, What you're saying is, okay, like you got the type T and the type S. S is an extension of T, right?
Uh-huh.
That means that if you have an object of that type S, that it will match the interface of type T. In other words, it can be used in place of it.
Yeah, you should be able to replace an object with any of its subtypes and it still work the same. I have another quote from Uncle Bob that's a little bit easier to understand. Functions that use pointers of references to base classes must be able to use objects of derived classes without knowing it. Like the idea is they don't need to care if they're using a derived class or the base class.
Right. In other words, they know what they're plugging into and they plug into that, and that doesn't change.
Mm-hmm. Now, this extends the open-close principle so that anything that uses a class must be able to use any extension of that class. But the thing is, if it's designed to use the extension,
it can't necessarily use
other extensions or the base class.
Right.
Because there may be things in the extension that it needs to function that are not in the base class.
Right. And this kind of goes into the whole type theory thing. And we probably should do a series on that, but it's going to be really hard whenever we do it. So I'm not overly looking forward to it.
So this is complicated, and this principle sets standards around the inputs and outputs of functions because of how complicated it is and how easy it is to mess up when you don't have a managed system that is preventing you from doing this.
Right. And a lot of this stuff is built into the newer languages that were designed to be object-oriented. Mm-hmm. And we've gotten better at this as time has gone on, because some of the early object-oriented languages, it was possible to really go off the rails with this stuff. Mm-hmm. And they've kind of figured out how we screw up on average and cut that down a lot.
Right. So the first rule states that there is covariance of return types in the subtype. Basically, you can pass in the subtype to a function that requires the parent, and it will return an object of the parent type. The next is contravariance of method arguments in the subtype. Or you can pass in the parent type to a function that requires the subtype, but this runs into trouble if you try to read the subtype from the parent. This is best for writes only.
Right. No new exceptions should be thrown by the methods of a subtype, except where those exceptions are themselves subtypes of exceptions thrown by the methods of the supertype. That sounds really nasty. The idea here is you don't surprise the other programmer, right? So like if they've got a catch block and it's catching exceptions coming in, that's done by type most of the time. It's going to look at it and go, okay, is this exception, does it match this signature? If it does, then do this. What you don't want to do is pass one back that they don't have a handler for. Like at the end of the day, that's what's going on. It's basically the same as having a return type. It's just not going the same way. It's semantically different. Now, don't use exceptions as a return method, please. But
yeah, I was about to go there. You saw my face.
Yeah. But like from an understanding the principle kind of thing, that's sort of what's going on. It's analogous.
Mm-hmm. In addition, to adhere to Liskov's principle, the subtype must meet certain behavioral conditions. Now, these are based on design by contract programming as defined by Bertrand Meyer. Designers should define formal interface specifications for components that extend normal abstract data types with preconditions, postconditions, and invariants.
Right. So a precondition is something that has to be true before the code is executed.
And a postcondition is something that has to be true after the code is executed.
Right. When it returns.
Right. And an invariant is a condition that has to be true the entire time the code is running.
So, in other words, the code can't change this thing.
So, with that in mind, these behavioral rules for Liskov's principle are preconditions cannot be strengthened by a subtype.
In other words, a subtype can't put any constraints on the caller that the caller can't be aware of.
Postconditions cannot be weakened by a subtype.
Right, because then, again, the caller is depending on something to be a certain way, and you don't surprise them.
And finally, invariants of the supertype must be preserved in the subtype. So if things are not changing in the supertype, they can't change in the subtype.
Right.
Going through that method.
The constraint of history rule prevents state changes in the subtype that are not permissible in the parent type. So subtypes can introduce methods that are not in the parent type, but these methods may allow changes that would otherwise not be allowed in the parent type. The history rule prevents this from happening. However, anything added in the subtype may be modified by that subtype. again, this goes back to the whole, like, don't surprise other programmers thing. If you think about what they're expecting, like Liskov totally makes sense. But until you do, then you deal with gobbledygook of subtype and this type and that type and phi and all, I think that's the Greek letter there. Is it phi, phi, faux fum? It's one of those. Anyway. So the I in S.O.L.I.D stands for interface segregation principle. That's business logic to clients communication.
We have another quote from Uncle Bob that says, "A client should never be forced to implement an interface that it doesn't use, or clients shouldn't be forced to depend on methods they do not use."
Right. And this, just as an aside, this is one thing I hated about ASP.NET 2.0's authentication bits and pieces, which you hadn't been around long enough to have had to deal with this. But there was one class in there, or you had to implement this one interface to be able to talk to their stuff, and it had like 30 methods, and you used like 2 of them.
That's annoying.
Oh yeah, because you had to implement it, and it wasn't clear, like, okay, which ones of these are going to get called. So what you end up doing is you put you make it where it throws not implemented exceptions in all of them, and then when it busts on one of them, you implement that one. Okay. It was not healthy.
That's just bad design.
Yeah. Well, this was pretty early days in .NET.
Okay.
And so there was a lot of stuff that wasn't present at the level that we have now.
Mm-hmm.
And so there was reasons for it, but man, it wasn't helpful.
Interfaces should be thin and fine-grained so that you have many interfaces, each doing specific work, as opposed to one large interface for everything.
In other words, you don't want an interface for a God class.
Oh, yeah. Well, you don't want God classes.
Right. I mean, like, it's the same problem, right? You're bringing in stuff, you're bringing in dependencies on things that you don't need.
This is intended to keep systems decoupled so that they're easier to refactor. Now, relating back to the single responsibility, this specifies that clients, or those calling an interface, should only see what they need, and that should give them all that they need.
Right. So they have a very... it's like a meeting agenda, right? Like, it's a bad meeting when there's no meeting agenda and everybody talks about everything. It's a good meeting when it's like, here's the list of bullet points. Think of that, but it's in code. It's an interface.
Well, on the other side of that, it's a bad meeting when it's not a list of bullet points, but it's a 3-page paper.
Yes.
Outlining what you're going to talk about.
Yeah. I've had one with 15. That was fun. We got lunch.
Well, at least you got lunch.
Yeah.
Interfaces are designed to abstract the methods used from the code calling those methods. They don't contain any data or any code, and interfaces tell the client or the caller what the method does and how it can be used, such as what inputs it takes in, what outputs it returns, and sometimes what side effects it has.
Right. And those side effects can be anything from throwing exceptions to, certain pieces of data are mutable during this call.
Right. A class that has all the data or code for an interface is said to implement that interface.
Right. And methods not used by the client should not be in that interface. That's what I was complaining about with the web stuff.
Yeah.
They should be based around the business or domain logic for the application. And any given interface should only contain the methods for the business logic that it actually uses. The
interface for controlling the speed of your vehicle isn't the same as the interface for determining if it needs more oil.
Right. And can you imagine how many wrecks there would be if those two things were swapped, or if you had to use a dipstick to slow down? Right? Like you had to pull it out or something? Like, that doesn't work. Like, part of this is a specialization of labor.
The thing is, you're not going to be checking your oil while you're driving your car.
Right.
So you don't need those interfaces to be the same.
Right. And, so it's just, most of this stuff is really simple when you put it in terms of real world objects.
Mm-hmm.
And that's the way you need to think about it, because that's where object-oriented programming came from, was observation of the natural world, not the other way.
Now, when a client depends upon a class with interfaces that the client does not use, that client will be affected by changes that other clients force on the class. Interface pollution happens when one interface inherits from another for just a few of its methods or subclasses.
Yeah, and that's why we'd say it gets what it needs and only what it needs.
Right. Each time an interface is added to the parent class, it has to be implemented in the subclass. Of course, if your subclass inherits from a class that implements the interface,
then you technically get that implementation. Yeah, you do, but
you see where I'm going with this, where it becomes a problem.
Yeah, but it could be, you could add a method that's like, do stupid thing for client A, and client B is implementing this thing, and now they see that client A is stupid.
Yeah.
Or something weird like that, or they accidentally call it and it has nothing to do with them, and it's hitting that other client's back-end system or something weird.
So like where I use this most is with my repository. So I have a base repository that has, the basic gets and posts for just, its generics and an interface for it.
Right.
And then all my specific repositories inherit from that so that I don't have to go in and just write a post for this specific, or a get by ID for this specific repository. It's there. I don't have to reinvent the wheel every time I have a new repository. And on my repositories, I can focus on, these are the specific things that I need for this.
Right. And not the other stuff.
Right.
And when you're dealing with a bunch of repositories or a bunch of unknown object types, you can go, hey, since you're using generics, right, you can say, get me the basic repository that, is of a generic type closing the type that's coming in, and do this thing with it. Because I don't really care. Just put this thing somewhere.
Right. And the benefit of that is when my controller, say I need to get an object that is not part of that pathway because they relate somehow, then I can use that generic type without having to instantiate a whole new repository.
Right. Especially when you get dependency injection and those kind of things in the mix. Like, that's what this stuff depends on.
Yeah, it decomplicates it, basically.
Yeah.
So finally, the D in S.O.L.I.D stands for Dependency Inversion Principle. Our last introductory quote from Uncle Bob. Thus, when working with abstractions, you work on a high-level view of your system. You only care about the interactions you can do and not how to do them.
Right. So that means that high-level modules should not depend on low-level modules. Both should depend on abstractions.
Abstractions should not depend on details. Details should depend on the abstraction.
And of course, that all sounds very ivory tower. So let's get into what that actually means.
So according to Martin Fowler, there are several ways to look at the dependency inversion principle, and I pulled this directly from his post.
Yeah, because he writes good stuff.
He really does.
So code should depend on things that are at the same or higher level of abstraction. High-level policy should not depend on low-level details.
You want to capture low-level dependencies in domain-related abstractions. And when we're talking high and low level, we're not talking like low-level machine coding. We're talking about within your app, the depth.
Right. So like you're dealing with your major domain objects and doing stuff on them. They don't depend on how stuff is saved to the database.
Right.
And the database saving stuff doesn't depend on how they're implemented either. They're both interacting with an abstraction.
Right. In traditional application architecture, the lower level modules, such as your service layer, your data access layer, are designed to be consumed by the higher level modules, like controller business policy layer. In this, higher level modules then depend directly upon the lower level ones. They directly call the methods in those lower modules, and the higher levels are bound to specific implementations. This limits the reusability of those higher level modules to where the dependent lower layers are available.
Right. So you can look at your higher level modules as essentially being orchestrators of the lower levels. I mean, that's the idea, right? That's why you're abstracting up. So that there's less crap to deal with higher up.
Yeah. Interactions between high and low level modules should be abstract. In this, the high level modules should be independent of the implementation details. So my controller, it knows, hey, there's a function that gets, the information I need from the database.
However, it doesn't know what version of Oracle you're using.
Right. It doesn't care. It doesn't need to know that information.
Right.
All it needs to know is, I need this information and here's the method I use to get it. Then it gets that information from the interface.
Right.
The low-level modules should be designed with the interaction in mind as it may need to change interfaces.
Right. So the other thing is your lower level modules, while they may know that, for instance, you're using Oracle, they don't know that object that it's packaging up goes to the web. Like, it doesn't care. It just passes through.
One thing that we do need to take into consideration is that the term inversion of dependency does not mean that lower level layers depend on the higher level layers.
Right.
It's more of a lack of dependency than an inversion. Both really should be dependent on the abstract interface between them. And this reduces the coupling of components without adding more code or coding patterns. So we'll close with an often quoted line from Euclid. There is no royal road to geometry. Simply learning and knowing these principles will not in itself make a person a better programmer. To really be able to understand them, you have to apply them. If you can't do that in the code base you have now, then work through practice problems applying them. As you use them, you will see why they are important and where they may not be the best choice. This is something that comes with time because it takes many experiences to get a full picture or understand how they can be applied. Whether you are just starting your career and learning the best ways to write code or have been at it for decades, there is much to learn from just applying simple principles to the way you code. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I'll say that these principles apply in larger areas of life too, and you'll see markers for that. One thing I've learned a lot just with the amount of stuff that we're doing is that when you have one piece of something that fails catastrophically and the rest of the system doesn't break, that's because that piece doesn't belong in that system, whether you put it there or not. The idea here is that when you see a failure, you need to like that. Or when you see a failure that's shaped like this, learn to treat that piece as separate from the rest of the system. This goes with your business, your personal relationships, those kind of things. If you have it in your head that two things cohered, they're tied together, and one piece fails and the other one is completely untouched, they aren't. And at that point, you need to reevaluate that relationship between those things. And this is really abstract. I put this down in response to some stuff that I noticed personally. It's a pattern of thought that you need to get into a little bit because it will help you in a lot of interpersonal relationships, business relationships, job relationships, those kind of things. So that pretty much wraps us up. That's all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.